Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome to Oxygen Alliance YouTube channel. My name is Janet Douglas and I'm a biomedical engineer for Oxygen Alliance. Today we'll tear down the Diamedica oxygen reservoir system. The main function of this oxygen reservoir is to serve as a backup in the cases where we have power failure whilst using an oxygen concentrator. Particularly, it is also used as an alternative supply of driving gas in the Diamedica cluster vent anesthesia machine. The oxygen vessels come in two different sizes, 20 liters and 100 liters. They can be used to drive the cluster vent anesthesia machine for up to 2 hours and 8 hours respectively. This system comprises of an oxygen source, which is an oxygen concentrator in our case. It also has an air pump and an oxygen reservoir. For today, we'll be using a 20-liter oxygen reservoir. The oxygen reservoir, also known as an oxygen vessel, is made up of aluminium and it is used to hold the oxygen. It weighs 6 kgs and its dimensions are 25 cm by 25 cm by 70 cm. The oxygen reservoir has an inlet port where we connect a tubing coming from the air pump to the oxygen reservoir. This tubing actually helps us in the flow of oxygen from the air pump to our reservoir system. We also have a flow meter, which is used to regulate the amount of oxygen being delivered to the patient. Its rating is at 5 liters per minute. Apart from that, we have a pressure gauge, which is located at the top of the oxygen reservoir. This gauge is there to monitor the amount of pressure inside the oxygen reservoir. We also have a safety relief valve which vents out excess pressure. It is preset at 7 bars. Finally, on the oxygen reservoir, we have casters, which allows the mobility of the tank to move it around at any location of the patient. The air pump also has a couple of parts that I would like us to dive in. So first of all, it has a power supply port. This is where we connect our power cable in order to be able to power our air pump. It also has a power switch, which is used to turn on and off our air compressor. Apart from that, it has an inlet port. The inlet port is specifically for oxygen. So this is the port that takes in oxygen from an oxygen source, which is an oxygen concentrator. We also have an outlet port for oxygen, which actually takes the oxygen from the air pump to the oxygen reservoir. Apart from that, we also have 2 cooling integral fans. These fans are rated at 12 VDC with a power rating of 1.1 watts. The first fan is located at the flank of our air pump, and the second one is actually found at the back of the air pump. So all these components, including the internal components that we'll also be diving into, are held by a protective casing. The protective casing is actually the black box that you can see right here. Now I'll open the air pump to show you the internal components. Once you open the protective casing, you'll see that we have this part which is known as the power supply unit. So this power supply unit is used to charge the battery. So in this case, this is our battery for the air pump.
So if you want to use the air pump, you have to also make sure that the switch here is on. It also has a fuse that is located here, and it's indicated with the word fuse. So in case where you see that the battery is not functioning properly, before you think of unscrewing or replacing it, you have to first check whether the fuse is in good condition or not. So you just slide it out. As you can see, this is the fuse. You can replace it if you have a new one in case this one is faulty or burnt, and then you check the performance of the battery after that.
So the major component of the air pump is the air compressor. So as you can see, this is our compressor here. We also have two fans, like our area stated. So the other one is for taking in air, and the other one takes out the air inside the air pump. We also have a battery, which is charged by the power supply unit. Apart from that, inside here we have a needle valve and also a fire brake. So the fire brake is recognized by the white color that you see. We also have a pressure switch. Now I'll take you through the electrical system of the air pump. Mainly the air pump is powered by DC. So when you connect your power cable, the power enters from this port and then it goes through this cable here to the battery charger. The battery charger is responsible for converting the AC voltage ranging from 100 to 240 volts to 12 VDC. Once the power has been converted, it comes out here through this cable. And then as you can see, this cable goes down to the battery. The 12 volts DC is used to charge the battery. So the battery is labeled positive and negative.
Now I'll take you through the flow of current from the battery to different components of the air pump. So as you can see, we have the red cables and the black cables. The red cables are for the positive side and the black cables are for the negative side. So I'll take you through the positive side first. So current flows from the battery through these positive cables to firstly to the power switch, which I'll show you in a moment when I'll be disassembling every component inside here. So from the power switch, there is another cable here that taps the power and it goes direct to this power cable connector. From the connector, it then goes to the pressure switch. When the preset value is at 5 bars, it then cuts the power to ensure that it maintains that pressure and that it doesn't go beyond the 5 bars. So from here, we can see that there's also another cable here that is tapped from the pressure switch and then it goes to another connector. So on this connector, we have 3 different cables and the smaller cables in red, they are for powering the fans. So we have 2 integral fans here. These are powered by these 2 cables. And then this other cable, it goes direct to the compressor. So it's used to power the compressor as you are using the air pump. So in short, that is how the current flows from the positive side to these 3 major different components inside the air pump. Now I'll take you through how the current also flows from the negative side of the battery to different components as well. So as you can see from here, from the negative side of the battery, it's going straight to this connector. And on this connector, we have 3 different cables identified by the black color. The first cable is the one that is coming from the battery. The second cable goes to the power switch as well, and it is the negative cable for the bulb that lights when you turn on the air pump. So we also have the third cable that goes to this wire connector. And as you can see, we also have three cables. The other ones are black and the other one is blue. So these two smaller black cables are also the negative wires for the negative cables for the fans. The blue one goes to the air compressor. So this is actually how the black or the negative side of the battery is connected to the different components. The other system that you would observe in the air pump is the pneumatic system. So now I will take you through the pneumatic system of the air pump. First of all, oxygen coming from an oxygen source, which is an oxygen concentrator, goes through the oxygen inlet ports. From the oxygen inlet port, through this pipe, it goes to the needle valve. So this needle valve is the one that controls the flow of oxygen inside the pump. From the needle valve, it goes straight to the compressor. So on the compressor, as you can see, there are labels showing the direction of air. So this is for the inlet, which shows that the air is going inside the compressor, and this other side is for the outlet that shows the point at which the air comes out of the compressor. So once the air enters through this port, it's compressed in the air compressor, and then it comes out through this port. As it comes out, it then goes straight and passes through the one-way valve. The one-way valve is here to ensure the one direction flow of the air, so that there shouldn't be any moment where the air will be flowing back into the compressor. From there, it now gets to the T connector. So on the T connector, as you can see in black color, it then goes to the pressure switch. So like I said earlier, the pressure switch is preset at 5 bars, and the moment the pressure is above 5 bars, it ensures that the compressor shuts off. So the compressor will actually shut off once the pressure is detected to be above the 5 bars that is preset. So going back now to the T junction or the T connector, the air then goes through the fire brake. So the fire brake is there to avoid oxygen piping fire. So it is also used as a safety feature to protect or safeguard the patient, so that you wouldn't see any cases where the fire breaks out because of the oxygen flowing through this pneumatic system. From the fire brake, it then goes through this tubing direct to the oxygen outlet port. So like I said earlier, on the oxygen outlet port, that's where we connect a tube that goes to our reservoir tank or our oxygen vessel. Let's now disassemble some of the components of the air pump. So I will disassemble the battery so that we can have an access to the connections of the power switch, as well as our compressor. So you can see that the battery is secured using a cable tie. So first of all, you have to cut this cable tie using a cutter. So you have to cut it. After removing the cable tie, you can now remove or disconnect the negative and the positive cables. So I will remove the positive side, and I also remove the negative side. So now you can take out the battery and put it aside. So inside here we can see this white stand. It's more like a battery stand. So for you to access the power switch connections inside the air pump, you have to unscrew the screws that ensures that this stand is fully secured. Now I will have to remove the screws. So we have 2 screws in front and 2 screws at the back. Now you can easily remove the stands and put it aside. When you remove the stands, you can now have a clear access to the cable that connects from the power supply port to the battery charger. You can also see these 3 cables. 2 cables are for the positive side of the battery and the black one is for the negative side. So on the positive cables, one cable is coming from the battery going straight to the switch here. The other cable is now tapping the power from the switch to the pressure switch through the connector, like I already explained. After having the access to the other wires or cables, we can now remove the compressor. So now let's disconnect the cables for the compressor in order to disassemble the compressor itself. So for us to do that, we can see these 2 cables, the blue and the red cable or red wire. So we have to remove this from the 3-lever connector that we have here. So for us to do this, first of all, you have to pull the lever to the maximum point. And when you do that, you can now pull out the cable out of the lever connector. When you also do that for the blue side, you also have to do the same for the red wire. So I'll pull the lever as well and then pull out the wire. So the moment you do that, you can see that the cable that powers the compressor has now been disconnected. Once you have removed the cable that powers the compressor, you can now remove the tubings for the pneumatic system. So for us now to remove the tubes for the pneumatic system, you first push the tubing clip and you pull the tube. And you do the same for the outlet of the compressor. You push and you pull. The moment you do this, the only remaining thing that you need to do is to unscrew all the screws that are holding this compressor. The screws are located under the casing. So for us to unscrew them, I'll have to close the air pump to secure everything inside it. And the moment you close it, you can now put it down to have access to these 2 screws and the other screw that is in the middle. So for you to unscrew these 2 screws under here, you will need a Phillips screwdriver. But then when it comes to unscrewing the one in the middle, you need a 4mm Allen key. So I'll first remove the ones on the sides. Please keep these screws at a safer place so that you don't end up losing them. I'll now use the 4mm Allen key to unscrew the one in the middle. Once you're done unscrewing, you can now lift the air pump. Be very careful when doing that, knowing the fact that the compressor is now loosened. Now you can open the casing and secure the cables properly. Create some space for the compressor And then once you do that, you can easily remove the compressor.
So here is our compressor. So this compressor is an oil-free single piston compressor that is powered by 12 volts DC. The compressor has stands. So the stands are 3 in total. So for you to assemble this compressor back, you firstly have to screw the stand that is located at the center of the casing. So I'll put this compressor aside and then I'll show you how to replace it. We're putting the stand inside, so use one hand. When you're bending it, you make sure that one hand is inside to locate the place, and then you carry your screw and then you put it here. Don't forget your Allen key, 4mm size that we used when we were unscrewing.
So now you can take the compressor and put it back inside. Make sure you align it with the stand in the middle. Now we can replace the cables and the tubings. So firstly, you have to replace the inlet tubing, the one that goes to the inlet of the compressor, by just pushing it inside. You also have to do the same with the outlet tubing, by just pushing it inside as well. After that, we'll have to replace these cables. So after that, we have to put these cables back to the lever connector. So the lever connector has to be open or it has to be pulled up. And then for the blue one, it was connected to the negative wires, so put it back and then you close or push the lever. You do the same with the positive wire. Then you replace the stand for the battery. So you align the stands. Once you align, you can now take the screws and then start screwing them back. Don't complete screwing until you make sure that all the flange screws are aligned properly. You can now do the same for the back side. After putting back the stand, you can also put back the battery. So you make sure that this battery is well secured like it was before. So you use a cable tie to do that. Now you can put back the cables. Do not forget that the red wires or the red cables were connected to the positive side of the battery. And the black ones were connected to the negative side of the battery. Once this is done, you can now close the air pump. Now, let me show you how we fill the Diamedica oxygen reservoir. It is recommended that we use an oxygen source, which is an oxygen concentrator, rating 10 liters per minute. In our case, we'll be using 2 oxygen concentrators of 5 liters per minute. And I will demonstrate how it is possible to use these 2 concentrators, 5 liters per minute, and still get an output of 10 liters per minute. Firstly, you will need to have a T connector. So this is our T connector. Apart from that, we'll need 3 tubings. One tubing will go to the first oxygen concentrator, the other one will go to the second, and the other tubing will come out as an output which will be connected to our air pump. So these are our tubing. This is the first tubing with a Christmas tree. And we'll connect this to an end of the T connector. You will do the same with the second tubing and connect it to the other end. Finally, you get the third tubing and connect it at the bottom end of the T connector. So once you are done with the connections, you can now connect one end, having the Christmas tree on the concentrator, one of the concentrators. And you also connect the other end to the other concentrator. Now, this is the connection. Once you have connected these tubings, you now turn on your concentrators. So, I'll turn them on. Make sure that the indicators of the concentrator have stabilized to the point whereby it's showing you the recommended purity. So in our case, we have the yellow indicator showing us low oxygen purity. So you have to wait for 5 minutes for it to stabilize until you see a green indicator on these concentrators. And also, you set your flow rate to 5 liters per minute, which is the maximum for these concentrators. As you can see, the indicators are now green in color, which shows that the oxygen concentrators have now stabilized. Now, you have to connect the tubing that goes to the oxygen outlet port on the air pump. So you have just to press it inside. Once that is done, you then connect your tubing from the oxygen concentrators to the oxygen inlet port of the air pump. Then you turn on your air pump. On the flow meter, make sure that it is closed so that you don't let any air outside of the reservoir tank. So as that will be happening, at this point, it means we are filling our reservoir with oxygen, and as it will be filling, the pressure gauge will be indicating the amount of pressure that is being built inside the reservoir tank. So with time, the gauge will be rising. So once the filling has been done, it will automatically switch off. So from there, you can now switch off the air pump and then go ahead and switch off your oxygen concentrators. And then from there, you can disconnect the tubing on the oxygen inlet port and also do the same for the reservoir. This is all we had for you today, and I hope you have learned something new. Please don't forget to like and share this video, as well as subscribe to our YouTube channel. Bye!